All right, guys. The solving quadratic square roots. We'll start with easy and then work our way up to difficult. Okay. First one, really easy one. You have x squared equal to some number, and let's make it a good number that's a nice square root, like 49. Okay. Anytime you have something squared on one side and then numbers on the other, solving with square roots is the quickest way to get an answer. Not necessarily the only way to get an answer, but it's the quickest way. I can take the square root of both sides, and that gets rid of the squared on the left side. The only thing I have to remember here is when I take the square root of a number, I have to use positive and negative, because positive 7 times positive 7 is 49, but negative 7 times negative 7 is also 49. So we get that as the two answers. Now, the way we did that the other day was we solved it like that, and we factored that as a difference of squares at x plus 7, x minus 7 as the factors. And there we got x equals 7, x equals negative 7 in the opposite order there. But it's both the same answer there. That works great when it's a number that's got a good square root. It doesn't work. Factoring just doesn't work when it's a number that's not a good square root number. Like if it were x squared is equal to 24. If I were going to do that with factoring, it won't factor. There's no way that works. But if I use square roots, I can get the answers. Because I take the square root of both sides. And remember, when you take the square root of a number, you introduce the square root to the problem. You have to use plus or minus. And then I think, okay, 24 simplifies. 6 and 4 is a good start. And then we got 2 and 3, 2 and 2. There's a pair of 2, so it's 2 radical 6. Those two are the answer. Positive 2 radical 6 and negative 2 radical 6 are the two solutions to that. Okay, that you could not have solved that one by factoring, because it just doesn't work, for difference of squares, because 24 is not a square number. Okay, so pretty easy. Let's go a little level up here to 5. X squared is equal to 80. Maybe something like that, where the x squared is not by itself yet. Can we get it by itself? Yeah, divide by 5. 80 divided by 5 is 16. And then you take the square root. So x equals plus or minus 4. Positive 4 and negative 4 are the two answers for that. Maybe you got x squared minus 7 equals 29. Is the x squared by itself? No. I can put it by itself. And then take the square root. Square root of 36. 6 plus or minus 6. Positive 6 and negative 6 are the answers for that particular equation. So solving by square roots can get you an answer really quick, whether it's a perfect square number or not. It really doesn't matter. Let's say we had something like x squared plus 7 is equal to, maybe it's 19 that it's equal to. What do you do for that one? Subtract 7 to get the x squared by itself, right? That's what I want. I want the squared part by itself. Doesn't matter what the squared part is. I want that part by itself. That's what we need for each one of these problems, to use the square root to solve it. So 19 minus 7 is 12. Then we take the square root of both sides. 12, break it down with the 4 and 3, 2 and 2. So 2 plus or minus 2 radical 3. Getting two answers the same way we would get two answers most of the time when we solved a factoring problem, because it's an x squared problem. Okay. When we were factoring, sometimes we only got one answer, but it's because we had the same factor twice. So it still counts twice. All right. Let's go up another level, maybe. Let's say we had, is that the right letter? Yeah. Maybe we had 3x squared is equal to, maybe a number 3 doesn't go into, like 8. Yeah, that's a good one. So if I'm going to solve that using square roots, what do I have to do first? Divide by 3, yeah. Good job. 8 over 3. And then, now the x squared part's by itself. That's what we wanted. So we can now take that, do the square root. But it's the square root of a fraction. So this is where, the reason we went over that yesterday. Square root of 8 over square root of 3. Look to simplify the denominator. Will 3 break down any? No, but we can't have a radical in the denominator. We've got to rationalize that. So what do we multiply by to rationalize? Square root of 3 on top and bottom. And that's going to turn into square root of 24 on top, and then square root of 9 on the bottom, which is 3. And then we simplify the 24. 8 and 3, 4 and 2, 2 and 2. We've done 24 already today. 2 radical 6. So we have plus or minus 2 radical 6 over 3 as the answer. And the plus or minus looks like it's with the numerator. It really doesn't matter. It's just out in the front of it. Positive 2 radical 6 over 3. Negative 2 radical 6 over 3. Two sorts of answers there. So here we see that fraction coming back that we talked about some yesterday. All right. Let's look at the next level. Let's put a fraction in the problem like on the left side. Maybe we got 2/3 x squared is equal to, I don't know, 17. Picking numbers. How do we get rid of that 2/3? Multiply by the reciprocal. Yeah, stuff y'all know. That part should be the easy part. Getting that x squared by itself. 3 over 2. X squared is equal to 30 plus 21 be 51 over 2. Can we take the square root now? Yeah. Plus or minus. Square root of 51. Square root of 2. Got a radical in the denominator, so we got to rationalize. Radical 2. Radical 2. That'd be 102 over 2. And if I try to break down 102, there's no pairs. So that's why I'm leaving it square root of 102 on top. Seems like a large number that won't break down, but it doesn't. No pairs to break it down with. Okay, so that's why we want to do there. Okay. If that radical, like if we had like a 4 in the denominator when we took the square root, it simplifies, so you don't have to rationalize then. It's only when there's a radical left in the denominator that you have to rationalize. Let's look at the next level of problem. And this is the highest level that we'll see in this particular section. So we had something like 2 parentheses x minus 5 squared is equal to, say, 40, like that. What's the squared part in that problem? The parentheses, that whole parentheses is the squared part. So we want to get that parentheses by itself. So what would we do to get the parentheses by itself? No. Can't do distributed property because order of operations says the exponents would have to happen first. But we don't want to multiply that out because that would kill our square root rule. So how can I get rid of that 2 that's in front if I can't distribute it? I can divide by it. Because it's multiplying 2 times that stuff parentheses squared. So the opposite of that would be that division. And that's going to give us x minus 5 squared is equal to 20. Now is the squared part by itself. When you get that squared part by itself, that's when you can use the square root property. Okay? So I'm going to take the square root of both sides. Don't forget your plus or minus. You've got to have that plus or minus in front of it or you'll lose one of your answers. Okay? So that gives us x minus 5 over here. The squared goes away. There's no need for parentheses anymore because there's not a squared out there. So we just drop that to just x minus 5. Then we want to simplify that radical if at all possible. So square root of 20. Break it down 4, 5. Pair of 2's. So 2 radical 5. Now we need to get x by itself. Technically, there are 2 problems that you could set up and work. One would be x minus 5 is equal to positive 2 radical 5. The other one would be x minus 5 is equal to negative 2 radical 5. But we can work it in one because that's not going to change any. So how do I move that 5 over to the other side? Add it. Yeah, they're subtracting, so I'm going to do the opposite and add 5. What I have to keep in mind is that 5 right here is not a like term to this because this is a 2 radical 5. You can't add a plain number plus that and get the exact answer. You can add them as decimals and get a decimal, but we want the exact answer here. So it's going to be 5 plus or minus 2 radical 5. So you really have 2 answers. One is the 5 plus whatever 2 radical 5 is. And then the other answer is 5 minus whatever 2 radical 5 is. Okay. Quite a bit going on in that problem. A little bit longer. Now, the others have been real short. So, I mean, we're getting to a little bit longer problem here. But it's not just incredibly difficult problems. Let's take a look at this one. Let's say we had just the parentheses x plus 7 squared. Excuse me. Minus 6 is equal to 22. How would we get the squared part by itself? Yeah, absolutely. It is that simple. You just add 6. That's going to be 28. And then is the squared part by itself now? Yeah, got x plus 7. That's the squared part. So what can I do now? Take the square roots, yeah. Once you get the squared part by itself, it's square root time. So that's x plus 7 is equal to, now I need to break down the 28. 14 and 2, 7 and 2, there's a pair of 2's. 2 radical 7. Then how do I get x by itself? Last step. Very good. Subtract the 7. That's going to be negative 7 plus or minus 2 radical 7. So we're trying to get the squared part by itself. Whatever we got to do to get that to happen, it's just like solving a regular equation. And then take your square roots to get your answers. Okay. Let's say we had one like this. Let's say it's 3 parentheses x minus 2 squared plus 8 is equal to maybe 57. Can't do that yet. Why do I have to move the 8 before I divide by 3? Order of operations is the right reason. You got to undo the stuff that's not attached here. Just like if it was the equation, and you guys don't have any problem if it's this. Y'all can solve that without thinking. It's the same idea, except for this is like your x. So you want to move the 8 first. So 57 minus 8 is 49, which is a good number until we divide it by 3. And it's not such a good number anymore. So that's the step that's going to get the squared part by itself. And that's what we need, is x minus 2 squared. It's equal to this fraction, 49 over 3. So now I've got the squared part by itself, so the step that I do then is what? Take the square root of both sides. Plus or minus on the side that's just numbers. Okay. That gives us x minus 2 is equal to plus or minus. And then square root of 49, we already know, right? 7. But on the bottom, we got square root of 3, which is the problem. So what do I need to do to that?
Multiply it by the square root of 3.
Yeah, multiply by square root of 3 over square root of 3. Good job. Rationalize the denominator is what that's called. If somebody ever asks you what you're doing, that's what I'm doing. I'm rationalizing the denominator. So that's going to give us x minus 2 equal to plus or minus 7 radical 3 over 3. Is x by itself yet? Not quite. One more step. What do I do? Yeah, just add the 2. Can I combine are these like terms, the 2 and that? No, that's got the radical 3 in it, so that means you're not going to put them together unless you were asked for a decimal approximation for the answer. That's the only time you would put these together. So adding 2 on both sides, 2 plus or minus 7 radical 3 over 3. And you found an exact solution to that. Okay. Fun times. That's about as tough as they get in this section. And that's a little long, but really not that, it's not super difficult stuff if you can simplify the radicals. So if you didn't look at any of 3 through 18 last night, then maybe that looks a little foreign and makes it look a little hard. Or maybe you just don't remember doing that in Algebra 1. Makes it look a little tough. But other than that, it's solving equations basically. So what I want you working on the rest of you got an hour left in class. So yesterday we did 269, 3 through 18. Today pick up 22 through 33. And that's the equation part. Okay, pick those up and see if you can do some stuff with those and work on those. And then 3-day weekend. Okay, so that's our lesson for today.